Today I'll talk about why you shouldn't use serializable isolation level with databases. What does that mean? Let's take a step back. Databases execute multiple transactions in parallel. Now when that happens, the transactions can interfere with each other by updating the same rows. Isolation is a feature in a database that prevents this from happening. You should read this Wikipedia article or other sources online to learn about this. Isolation is tunable. You can opt for more or less isolation. This is expressed in the concept of levels. The highest isolation level is called serializable. It prevents multiple transactions from interfering with each other in any way. A lower level is called repeatable read, and it's the default in MySQL and probably other databases. And below that there are even weaker levels of isolation which I won't talk about. So when there are multiple options, you may think that serializable would be the best. You don't want to have bugs or data corruption caused by another transaction running in parallel with your transaction. So that is what I thought and changed the isolation level once, and that really killed performance, latency, which increased from 10 or less than 100 milliseconds all the way till 10 seconds at the peak. So that's like 100 or multiple hundreds of times increase in latency. Obviously we rolled it back immediately. So don't use serializable. Let's understand this a little better with some sample data. Assume we are running an app of some kind or a service, and you have a users table. It has a name, an age, and a last email date. Now let's say you want to offer something like a marketing offer to people in their 20s. So you write an SQL query. This is the query. Select star from users where age between 20 and 29. Assume this is an integer. And then you send the mails, and then you update the table to select the last email date to the current timestamp for these users. Obviously it's not valid SQL, but you get the point. I think here you should say select for update or something. Forget the syntax details. And you are doing all three in a transaction. When you do that, the database prevents other transactions from interfering with your transaction. So let's take a bunch of example transactions and see how they would work. We have a bunch of scenarios to test out, and we'll see how they work under repeatable read and under serializable. First, let's look at repeatable read. Let's go through these one by one. Before that, I'll tell you how repeatable read works. When you execute this query, select for update star from users where age is between 20 and 29, the database identifies the rows and then it locks those rows, which I'll show in red color, until the end of this transaction. So nobody can update these two rows until we are done updating the timestamp here. So let's say someone else is also setting the timestamp, they'll have to wait, or changing any of these, age or name, the entire row is locked. So let's discuss these use cases or these queries that can be running in parallel with our transaction. The first one, Ramesh turns 35. It is not allowed to run in parallel because it is locked. Ramesh is in red. Delete Ramesh. That also is not permitted. The locking prevents both edits and deletes. So both are disallowed. Satish turns 25. Sure, he's not locked. New user Samira 25. Sure. Repeatable read does not prevent inserts. Now notice that Samira is in her 20s. So it at a logical level interferes with this transaction. If this had executed first, then the result would also include Samira. But because this transaction got executed first and then Samira got executed midway through, she is not included. So that is why repeatable read is a weaker level. So you can create a new user. As I said, the locks prevent edits and deletes, they don't prevent inserts. Because how can you lock a row that isn't there? What about Satish changing to Satish Kumar? Yeah, he's not locked. Satish turning 11, yeah, he's not locked. This and this are different because if this were to execute, Satish would enter the range 20s. You're creating a new user, Anand 50, yes. You can delete Neha, she's not locked. So these are the things that you can execute in parallel with this transaction when you are using repeatable read. Now let's look at serializable. It's basically the same as repeatable read. In many cases, the first two are disallowed in both. The last four are permitted in both. But these two middle rows, 4 and 5, behave differently. These two highlighted ones, right? Let's take this case. Satish turns 25. I told you earlier that repeatable read does a query, identifies some rows and locks them. Serializable locks the range itself, which means no new row can enter the range. So when Satish turns 25, he is going to enter the range of 20 to 29. And serializable uses a range lock. The range lock prevents not only the rows which are already in the range, but also any rows from entering the range. That is why this row cannot enter the range by turning 25. You also can't create a new user Samira 25 because she would enter the range. So in both cases, you have a row that is entering the range. In this case, an existing row is entering the range. In this case, a new row is created within the range. But still, the range lock protects the entire range. Nothing can be added to the range or change within the range. So that is why it is a higher form of isolation. So this is a difference between repeatable read and serializable. So when you prevent more transactions running from parallel, running in parallel, that will hurt performance. Because to get the maximum performance, you should have maximum concurrency. The database should be allowed to do as much as it wants to do in parallel. When you come in the way and force things to happen one after another, it slows things down. Which is why, as I said, the latency shot up. Everything was getting queued. To give you a real world example, imagine you go to a restaurant. Say there are 40 people in the restaurant, or 20 people, let's say, who have a pending order. They have ordered a dish and they're waiting. Let's say there are 20 such people. And let's say there are 20 waiting patrons, right? And let's say each dish takes 20 minutes to cook. Now, if they run in parallel, let's assume there are enough chefs and enough stoves that you can cook all of them in parallel. The waiting time would be 20 minutes. Actually, this is perhaps not realistic, right? You may not have this much, but we'll just go with it. If it is serial, you have only one stove, only one chef, and the chef is told until you finish the first dish, you cannot even start the second dish. He would say, but I can chop up the onions and keep them ready. You say, no, you can't do that. That's serial. Then the wait time is 20 minutes into 20, which is what? 360 minutes, which is 6 hours. You can see how the waiting time increased from 20 minutes to 6 hours when you forced everything to run in serial. That is what was happening here. That is why you should not typically use serializable with a database. If you'd like me to help you with your tech, my consulting link is in the description.